Intro. Welcome back to our channel. Today, we're diving deep into a critical topic in the world of machine learning and artificial intelligence, building a production-ready AI workflow. Specifically, we will explore how to integrate continuous integration and continuous deployment, or CI/CD, into your machine learning models. If you're an AI engineer, data scientist, or a tech enthusiast eager to learn about optimizing your workflows for AI, this video is for you. Let's get started. Section 1: Understanding the AI Workflow. Before we delve into CI/CD for AI, let's first understand what a typical AI workflow looks like. Generally, an AI project can be broken down into several key phases, including data collection, data preprocessing, model training, model evaluation, and deployment. Each of these stages is vital, and success in one phase can significantly impact the next. The initial phase involves gathering data from various sources. This could include databases, APIs, or even web scraping. Once the data is collected, it needs to be cleaned and pre-processed. This stage is crucial as it ensures the quality of the data that will be fed into the model. Following pre-processing, the model training phase begins, where we select algorithms, train models, and fine-tune hyperparameters. After training, we must evaluate the model's performance using metrics that are relevant to the problem domain. This phase determines whether the model is ready for deployment. If it is, we move on to the deployment phase, where the model is integrated into production systems to start providing real value. However, maintaining a consistent and efficient workflow across these phases can be challenging, especially in teams where multiple engineers and data scientists collaborate. This is where CI/CD comes into play. Section 2: What is CI/CD? CI/CD stands for Continuous Integration and Continuous Deployment. It is a set of practices that enable development teams to deliver code changes more frequently and reliably. Continuous integration refers to the practice of automatically testing and integrating code changes into a shared repository. This process helps to detect issues early, ensuring that the codebase remains stable and functional. On the other hand, continuous deployment automates the release of code changes to production. This means that any code that passes automated tests is automatically deployed, reducing the time between development and delivery. Together, CI/CD helps teams maintain a high level of quality and efficiency in their software development process. Section 3: The importance of CI/CD in AI workflows. Now, you might be wondering, why is CI/CD especially important in AI workflows? The answer lies in the unique challenges presented by machine learning projects. Unlike traditional software development, machine learning projects involve not only code but also data, models, and sometimes even hardware considerations. The integration of CI/CD into AI workflows allows teams to address several challenges. 1. Rapid iteration. Machine learning models often require frequent updates as new data becomes available or as research advances. CI/CD enables developers to iterate quickly, experiment with different models, and deploy improvements without significant downtime. 2. Quality assurance. CI/CD practices come with automated testing, which is essential in data-driven projects. It ensures that changes to the model or data don't introduce new errors, thus maintaining the integrity of the workflow. 3. A collaboration. In a team working on AI, different members may focus on data preparation, model training, or deployment. CI/CD fosters collaboration by providing a common framework and tools that everyone can use, ensuring smooth integration of individual contributions. For scalability, as AI projects grow, the complexity of managing models, data, and infrastructure increases. CI/CD pipelines can scale to accommodate larger datasets and more complex models, making it easier to manage production-ready workflows. 5. Version control. In machine learning, models and datasets should be versioned to track changes over time. CI/CD integrates version control systems, allowing teams to monitor the evolution of models and datasets and revert to previous versions if necessary. Section 4: Setting up a CI/CD pipeline for AI. Now that we understand the significance of CI/CD in AI workflows, let's discuss how to set up a CI/CD pipeline specifically tailored for machine learning projects. We will go through this step by step. Step 1: Version control. Start by setting up a version control system, such as Git. This is crucial for tracking changes in both your code and your datasets. Create a separate repository for your model code and another for your data. This separation ensures that changes to the codebase can be managed independently from changes in data. Step 2. Automated testing. The next step is to implement automated testing. This can include unit tests for your code, integration tests to check the interaction between different components, and model validation tests to assess model performance on a validation set. Using frameworks like PyTest for Python can help automate unit tests, while libraries such as scikit-learn offer utilities for model evaluation. Step 3. Building the CI pipeline. Now, let's set up the continuous integration pipeline. You can use tools like Jenkins, GitHub Actions, or Circle CI to automate the process. The CI pipeline should include steps 4. 1. Pulling the latest code from the repository. 2. Running automated tests. 3. Building the model if tests pass. 4. Storing the trained model in a model registry, like MLflow or DBC. This pipeline ensures that every change made to the code is automatically tested and validated. Step 4. Model registry. Integrating a model registry is essential for managing different versions of models. This allows you to track which version of the model is currently deployed and make it easier to roll back to previous versions if necessary. A model registry can also store metadata about the model, such as training parameters and performance metrics. Step 5. Continuous deployment. After the CI pipeline successfully builds a model, the next step is to set up continuous deployment. This involves automatically deploying the model to a production environment. Tools like Kubernetes can be very useful here, as they allow for scalable deployment of machine learning models. You can use a containerization platform like Docker to package your model with its dependencies, ensuring consistency across environments. Step 6. Monitoring and feedback loop. Once your model is deployed, it's crucial to monitor its performance continuously. Implement monitoring tools to track key performance metrics, such as accuracy, latency, and resource utilization. If the model's performance degrades over time, it's essential to have a feedback loop to capture this data and use it to retrain the model. This mechanism helps in maintaining model accuracy and relevance in a production setting. Section 5. Challenges and best practices. While implementing a CI/CD pipeline for AI workflows brings numerous benefits, it also comes with its own set of challenges. Here are some common challenges and best practices to overcome them. 1. Data management. One of the biggest challenges in AI is managing data. Ensure that your data pipelines are robust and can handle data versioning effectively. Use tools like DBC or Delta Lake to manage data changes. 2. Model complexity. Machine learning models can be complex, and deploying them often involves tuning hyperparameters and dealing with dependencies. Ensure that your CI/CD pipeline can handle these complexities by including comprehensive testing and validation steps. 3. Collaboration and communication. In teams with multiple members, maintaining clear communication is crucial. Use collaboration tools like Slack or Microsoft Teams to keep everyone updated on the CI/CD process and any changes happening in the project. 4. Documentation. As with any project, thorough documentation is essential. Document your CI/CD processes, including the rationale behind decisions made and instructions for running the pipeline. This will help onboard new team members and provide clarity. 5. Iterate and improve. The CI/CD pipeline is not a set-it-and-forget-it solution. Continuously evaluate and improve the pipeline based on team feedback and performance metrics. Regularly update your testing strategy and tools to keep up with technological advancements. Conclusion. In conclusion, building a production-ready AI workflow through the integration of CI/CD practices is a game-changer for machine learning teams. It allows for faster iteration, improved quality, enhanced collaboration, and better scalability. By setting up a CI/CD pipeline tailored for AI, you can ensure that your models are always ready for production and that you can respond quickly to changing requirements or new data. We hope this video has provided you with a clear understanding of how to incorporate CI/CD into your AI workflows. If you have any questions or want to share your experiences with CI/CD and machine learning, please leave a comment below. Don't forget to like this video and subscribe to our channel for more content on AI and machine learning. Thanks for watching, and we'll see you in the next video.